Hi everyone, so in this video we will be discussing this lab on limiting reactants. Specifically, we are working with a copper and silver nitrate reaction. So we are reacting silver nitrate, which is an ionic compound, and you can tell that based off of having silver, which is a metal, and nitrate, which is a polyatomic ion, which is all nonmetals. So that's an ionic compound, and then you have copper metal reacting. So just to give you an overview, we have in part 1, you will make the measurements that you need in order to be able to predict how much silver is produced, and then in part 2 you're measuring how much silver was actually produced. So prediction versus how much was actually produced. That's the difference there. And then we'll just have you think about why that might have happened. So part 1, we are describing the reaction. So honestly, it really starts with this and getting this down pretty well, which is writing your balanced chemical equation. So whenever we go to the next screen after I'm kind of done explaining this part, I will show you how you can get started. So that's your first part of this lab. That's really important. If you get this down, everything else will fall into place. And there's some follow-up questions for that related to the balancing of this reaction. So if you have this reaction correctly written out and correctly balanced, then everything should add up and go well for part 2 and part 3. So in addition to that, you are also determining the molar masses of copper and silver nitrate. So copper, you look at the periodic table, you look for this is just an element by itself. And then for silver nitrate, you are going to have to add up the molar masses for silver. And then you are going to have to look at your polyatomic ion chart and see what nitrate is composed of. And it happens to be 1 nitrogen and 3 oxygen, so you're going to add all that up, and then that's going to give you the mass of silver nitrate, and then finally just of silver. So notice right off the bat, that's what we're working with. We have copper, we have silver nitrate, and then we have silver by itself. So that kind of gives you a hint straight away of what's going to be in my balanced chemical reaction, right? So let's talk about that up first. So we know we have copper and silver nitrate, right? That's all that we are told in our problem. Copper, the symbol for that is Cu. And once you actually look at the video, this kind of makes a lot more sense because you see that copper is a solid, but that's what it is in its elemental form. And then silver nitrate, like we said, is Ag. That's the symbol, that's the metal. And then nitrate, this information comes from your polyatomic ion chart, okay? So the formula for nitrate is actually NO3 minus, and the charge for silver is actually plus. So when you learned about ionic compounds, you learned that for ionic compounds, when you're trying to write out the formula, all you do is crisscross the numbers, and these both happen to have a 1, right? It's +1 and -1, so it ends up just being AgNO3. Now we are starting off with AgNO3 in solution. So this means that it is aqueous. Now the reason we know this is because otherwise this reaction wouldn't happen. You wouldn't have a liquid mixing with your solid copper. So what we have so far is copper plus AgNO3. Okay, and what you need to figure out is what happens. So instead of just giving that away, because I always want you to really critically think of what's going on, we are going to instead look at the video and I will kind of guide you there. Sorry about that. So as you can see, there's different trials. You will first use trial 1, and then later on number 4 on part 2, you're actually going to pick a trial based off your birth month. So that's where it kind of deviates there. But we're all starting with trial 1 at the beginning. And this is kind of an interesting reaction to watch. So I kind of want to highlight what's going on here. But you have your silver nitrate. It says it right there. It's kind of hard to see, but that's silver nitrate. And you can see that we are pouring that into this beaker. And obviously you're supposed to be recording the mass. Okay, and then we add the water. So like I said, this is an aqueous solution. And let me delete this out. Like I said, this is an aqueous solution, and you literally just saw the water being poured in. So it was a solid, we added in the water, now it's a solution. So that's what I was referencing when I meant aqueous. So now we have that solution. And then there's a piece of copper. It's solid. So like we said, once again, it's solid copper. Now, and sorry for flipping back so much, but hopefully that helps make the point. Now we can see that the reaction is happening over time, and you can see that the copper is looking a little bit funky. But what's actually happening is that solid silver is forming. So hint, hint, that's what's going on here. You're forming solid silver, and that's what you see on that. So the silver is basically being kicked out of this compound by copper, and copper is actually joining with NO3. So I'll leave it at that for you to continue on. Now, what's going on with the questions? So this happens in these 4 different trials, just in different masses and different ratios. But for trial 1, you just record how much silver nitrate you started with and how much copper we started with. Another thing that you also record is how much, cancel. So this one is incomplete. Now, for the rest of them, and I'm just going to fast forward because it's basically the same thing. But of course you have the same reaction occur. And then so in all of the trials on part 2, you will see that all of the reactions end in incomplete. That's for a reason. That's because for this part, that's where we are kind of stopping. So the purpose of part 2 is that you are going to calculate how many moles of copper, how many moles of silver nitrate you started with. Okay, so that's your first thing that you have to do. That's the first thing on your to-do list. And I'm going to show you an example of how we do this, right? So from there, you will determine the limiting reactant and then how much silver should be produced theoretically, right? So You're going to do this for 2 times. So you're going to complete that all over again, but for a different trial. Okay, so it's just the same thing twice in part 2. So let me show you how you would go about that. So let's say this is a reaction very similar to, let me take this off. So let's say this is a reaction very similar to what we're working with in this lab. I was trying to get it full screen, but it's not working. Anyway, here we have another reaction with also silver nitrate, but it's reacting with something a little bit different. So this is slightly different, but the point that I want to make here is how to show you to calculate limiting reactant. Okay, so that's really what I want to get at here. So notice that we start with unbalanced. So kind of on that similar note, we always check if everything is balanced in your chemical equation. So I'm going to do this faster than I usually would when I'm teaching, balancing equations step by step. So, don't think I'm just rushing for no reason, but we're kind of past that in the class. So that's why I'm kind of taking it a little bit faster. So there's 2 Ag on this side. So that's why I balanced that out. But that made me have 2 nitrates. So I'm going to balance this out. And that's pretty much balanced out now. Yeah. So now it's balanced. And I have the measurements of each reactant, right? AgNO3 and this mass of H2SO4. So in the exact same way where you just measured the 2 different masses of silver nitrate and then copper, and then you have to calculate them to moles, we're going to do that. So we are starting by converting to moles. So I am starting with 34.7 gram AgNO3. And 28.6 grams H2SO4. So off screen, I went ahead and got the molar masses for AgNO3 and H2SO4. So you would do that by adding up the masses of all the elements in each compound, right? So what I'm going to do is set each of those up so that grams cancel out. So for my AgNO3, I'm going to put the 169.87 grams AgNO3 at the bottom. And then at the top goes 1 mole AgNO3. Okay. And same idea here for my H2SO4. And then 1 mole at the top. Okay, so for the purposes of your lab, notice that you are stopping there and you're figuring out how many moles. So for example, for copper, you determine the moles that you had present at the beginning. And then for silver nitrate. So for your lab, you would sit there and calculate this first. You would say, okay, this equals, blah, 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 however many moles of AgNO3 and H2SO4. For your lab, it's silver, nitrate, and copper, right? So same idea. You're going to calculate moles of AgNO3. You're going to calculate moles of copper. Remember, this is an example problem that will help you model and figure the lab out. For us, we're actually going to take it a step further. So for step 3, we are actually going to convert both of these to product. Now, the reason for this is to determine which one of these is the limiting reactant. These are both reactants. We have AgNO3, we have H2SO4. One of them is going to be used up first. That's your limiting reactant. So to determine which one is used up first, we have to see which one produces less product. So to do that, all you need to do is convert to either one of these products, either Ag2SO4, silver sulfate, or to your nitric acid. So you can convert to whatever you want. In our case, for our lab, you're only converting, you can convert just to silver, so it's not really that big of a deal. You don't have a choice. But here we have a choice. So that's our step 3, and I'm going to circle it so you know what this next step is. So I'm going to go ahead and convert just to silver sulfate, just to be simple. So the ratio is that for every 2 mole of AgNO3, I have 1 mole, right? 1 mole of Ag2SO4 form. So that's what I'm going to write here. 2 mole of AgNO3, I have 1 mole of Ag2SO4. I'm going to convert to the same product for both of these reactants. So for H2SO4, the ratio is that I have 1 mole H2SO4 for 1 mole of Ag2SO4. Okay, so notice we're converting both of these to the same product. That is intentional. Like I said, we need to see how these compare to each other. So whichever one gives you the least amount of product. So let's say, and I'm gonna actually calculate these off camera real quick. Okay, so I went ahead and calculated out how much each of these would produce of my product Ag2SO4. And you can see here that my AgNO3 is giving way less. So I'm trying to find a marker that you can see. Okay, so my AgNO3 ended up giving me way less product. So what this means is that AgNO3 is my limiting reactant, and H2SO4 is my excess reactant, my excess, like it's in excess. So let's go back to the lab to connect this all together. So notice that it tells you to determine moles, so we did that. And then it goes straight to what's going to be the limiting reactant. So you have to do this exact same thing, but for your particular reaction in the lab. And then you have to determine how many grams of silver would be produced. So basically how many grams of product. So what you would do is take this amount right here, the 0.102 mole. For, this example, it's Ag2SO4, right? And what you would do is convert this to mass. So you would take 1 mole Ag2SO4, and here at the top you would put the molar mass amount, right? So it would be molar mass of your Ag2SO4 in grams, right? And then that would give you mass of Ag2SO4. So it's just an extra step. Once you figure out what's the limiting reactant, you take it an extra step, convert it to mass, 2 grams. So that's what you would do for this last step. Now, finally, in part 3, they actually go ahead and finish up those reactions. So remember in part 1, you didn't see the whole reaction. So here what actually happens is they allow the reaction to be complete, and then they separate out the silver that formed from the copper and from the solution. So they filter out the solution, and then they take out that wire that was once copper, and they have now the silver by itself here on the filter. So look at what happens. They take out as much as they possibly can. The silver keeps accumulating here on this filter. They're filtering. There's a suction line right here that's causing the liquid to go down. There's a drying period of that silver, and then they finally weigh it. So that's what's going on there. And then the rest of your copper. So you have to determine, again, what's your limiting reactant. Now, notice right here, how many grams of silver were produced? How many were actually produced? So that's where your measurement of mass comes in, right? How does this compare to your prediction? That's when you go back to your calculation and you compare it to however much you calculated. So that's where the idea of, or the fact, your prediction may not exactly match the actual amount of silver at the end. What are some reasons that you think this may have happened? Okay, so I took you through all the steps, all the different parts. Sorry that I was kind of flipping back and forth a lot, but I hope that me actually calculating things out gave you a good model. As always, if you have any questions at all, please don't hesitate to let me know. But otherwise, thank you for watching this video, and good luck on the lab.